Hello, my name's Antoine Victor, and I'll be your instructor for this DevOps training. In this training, we're going to look at what is DevOps, the DevOps Lifecycle, DevOps Tools, talk a little bit about version control, and then we'll get into CI and CD, that's continuous integration and continuous delivery, and then we'll follow on with configuration management, containerization, and finally finishing up there with monitoring. So let's go ahead and dive right in with a definition of DevOps. So what is DevOps really? Well, DevOps largely is a cultural shift. It's an organization-wide cultural shift towards delivering business value to the end customer. Now, this means that development and operations both have to work together. Now, because DevOps is a clipped compound, which includes only development and operations, it might seem like DevOps is just for developers and operations staff. But the reality is, if we were to include everything that DevOps really contained, DevOps containing development and operations, obviously, but also quality assessment, security, configuration management, infrastructure management, network management, and so on and so on and so on. The name wouldn't sound cool. It wouldn't be a good marketing term anymore. So let's assume for now that DevOps includes not just development and operations, but everything on the software delivery pipeline from idea to business value, making it into the customer's hands. So developers continuously want to develop and test code. So they're building new features. They're rewarded for delivering new features to the end customer. On the other hand, the operations team is in charge of keeping the network and the production software in a running state. So for them, less changes are better. So you can see we've got kind of opposing missions here between development and operations. Development wants to deliver new features, but the operation of delivering new features tends to cause downtime, which the operations team are rewarded for maintaining the opposite of that, which is uptime. So in order to get these guys working together, the development team and the operations team working together to enable continuous deployment, we have to automate a lot of these historically manual processes. So what we're really talking about here is the DevOps lifecycle, or the software delivery lifecycle, where we plan, and again, because we're talking about the entire team working together here, we're planning, but not planning everything. We plan just enough to get the next iteration done. And then we code, but just enough to complete the features that we plan to deliver in the coming release. And then we compile or build that solution. And once we get a successful build of that solution, then we go on and test that solution. And only on successful completion of all of those tests do we move on to the next phase, where we integrate the code that one team member has just submitted, got a successful build on, and then a successful test run. Then we take that code and we integrate it with all the code that was written by the other developers on the team. And then we test it again. And once we are successful with that integrated build and that integrated test run, then we can move on to configuring the environment that we're going to deploy this successfully compiled and tested solution to. That's where configuration management comes into play. It's best to avoid configuration drift and incorrect configurations by automating this process of configuring those servers that we're going to deploy our solution to. So with configuration management and automated configuration, our goal is to automate this process so we can be more consistent and reliable. And once we've configured the system that we're going to deploy to, then we want to use automated deployment to deploy to those systems that have been configured in a consistent way. We want to now deploy to them in a consistent and reliable way. And finally, once those solutions are deployed successfully into our stable, consistently configured environment, we want to monitor the ongoing use of those solutions to make sure that users are getting the features and the performance that they expect from the solution that we've delivered. So let's start at the beginning. Let's say we want to build a website for a company. We might have a customer that comes to us and says, hey, I want to build a new website for my organization. And we might respond, you can use DevOps tools and techniques to build your website and streamline your delivery process. Hey, that sounds like a great idea. Let's do it. So let me hire some developers, testers, and operations guys who can develop and test and maintain the website. And then after gathering all the requirements, the developers can start building the code for the website and store each version of that code in a source code repository. Now, for now, we'll call it GitHub. We'll say we're using GitHub. So we've got a couple of developers, and then we've got our GitHub repository to store all of our solution artifacts. So at this point, we've done a little bit of the planning. We've collected some requirements for our customer. We've started on the coding. We've stored some of the code in our local Git repository. Or maybe we were using the Microsoft stack, and we might be using the tool formerly known as Team Foundation Services. It's now called Azure DevOps. But as far as source control, uses the same foundations as Git. So we get our code into version control. So we might have multiple files that the developers have created. Developers are working on file 1, file 2, file 3, and they check those files into the GitHub repository as version 1. Another team of developers might be working on different features that might impact those same files. So they're working on file 3, but have made a couple versions of it, a couple of iterations to it. So they're on file 3.3, while team 1 is only on file 3. As we merge those different branches of changes together, we create version 2 of the solution. But if anything goes wrong anywhere along the way, we have kept those branches of changes separate, so one will not affect the other. This is the benefit of version control and source control tools like Git and GitHub. So the basic architecture of Git here, we have a working directory. We've got a local staging area where we prepare changes that we've made to be committed to the local repository. And then to share those changes with other developers on the team, we can push the changes out to a remote repository. To receive changes that other developers have made or other team members have made, we can pull those changes down from the remote repository. So back to our website project here. Now the developers have built the code using whatever tools they chose to use, whether they be .NET, Eclipse, or some other editing tool. We can then take that code and make sure that that code is valid by compiling it, packaging it, and then having the code verified by our quality assurance team. Now, in order for other team members to access this code, it's best if it's moved to that central repository, the GitHub that we were talking about earlier. So our developers write their code, they compile it, make sure it runs, and the tests all pass locally, and they can push that out to our central repository in GitHub. Now, we've talked about planning, and we've talked about testing, and we've talked about the compiling and the source code repository, but we didn't really talk about how that compiling is being done. So one of the ways that we might build Java code is by using a tool called Maven. Now, Maven is what we can use to define how our build is going to be done and automate our build process. So once we have that planning and building phase done, our solution has been tested and stored in version control, we might want to run some additional tests. For that, we need the testers. The testers are going to test the code that we built to make sure there are no errors that perhaps weren't caught by our automated testing that was part of the development process. So the testers are going to perform functional tests. They may rerun some of the unit tests created by the developers, system tests, and user acceptance tests to fully vet the solution to make sure that it's ready for prime time. So again, at this point, we've done a little bit of planning, we've done some coding, we've done some building of that code, and some automated unit testing of that code, and now we've passed it off to the QA team so they can do more exhaustive testing of that solution. Now, some of the additional tests that the QA team might run would be UI automation tests, exploratory tests, smoke tests to find issues that may not have been exposed by the low-level testing, unit testing that developers may have done during the development process using test-driven development. Once the QA team is finished doing that additional testing, making sure that we didn't miss anything with our automated testing process, then the operations team will need to integrate those changes along with anything that's already out there in production, maybe a previous version of the solution, existing data from an old database, or what have you. We can use continuous integration to make sure that all that code, all those changes that are being made by different team members is compiled and tested and deployed together on the production servers in a consistent way. So again, we've gone from planning to developing, or coding rather, and building that code and testing that code to integrating those changes with changes that the other developers on the team have made, and finally running additional tests, and after all of our tests are passed, pushing that solution out to production servers or production-like servers as we prepare for additional tests like load and stress tests. Now, this automation process of moving these resources out into the QA environment and on into the pre-production staging environments, and finally off into production, there are several tools that we can use to automate this process. Some of the more common tools listed here on the slide: Jenkins, Bamboo, and Travis CI, that's continuous integration, and of course Azure DevOps, not here on the slide. So a common example of using CI and CD in Jenkins is, again, we have our developers doing their work, hopefully writing their tests first, so that when they complete their work, they can commit their work to our source code repository, and that act of committing the work to the source code repository can cause a tool like Jenkins to automatically fire off a continuous integration trigger to build that solution, test that solution, and if it passes, potentially deploy that solution off to the next environment. But if it fails, we can reject that check-in to the repository and send notification back to the developer or other team member that introduced that defect, allowing them to fix that defect before it causes any problems for other team members. Now, of course, if that build and that test run passes, then Jenkins can automatically move that change, that version of the solution, onto the next environment. Now, that next environment in this case is the QA environment, where now the testers have access to that solution, and the testers can perform more exhaustive exploratory testing, user acceptance testing, and so forth. If they then find any errors, then they can push that feedback back down to the development team, who can then fix those issues and then resubmit that code through the continuous integration pipeline. Now, if the testers don't find any defects, then they would promote or approve that solution for promotion into the production environment. Or again, we might have a more complex environment where we push from QA into a staging environment, where we then continue to run load and stress testing. So far in our CI/CD pipeline here, we have the developers making the changes, we have the developers pushing those changes into a code repository like Git, we have the build system or the continuous integration system like Jenkins, detecting that change in Git and then automatically compiling and testing those changes submitted by the developer. And on the test framework side, we have unit tests, which are most likely written by the developers as they're writing the code or before they write the code, if we're using test-driven or test-first development. And then we have web UI testing done with tools like Selenium, and then integration testing, which could be additional unit tests run with those UI tests and other acceptance tests on our integration server. Now, as we move on from continuous integration to continuous delivery and continuous deployment, there are other tools that we can employ, like Serena and Pivotal CF, as well as Google's cloud platform, Azure, and Amazon's AWS, to assist in this automation of delivery and deployment. So a textbook definition of continuous delivery is to be ready and able to deploy any version of our solution to any supported platform at any time. Continuous deployment is basically the same thing, but without the ready and able. With continuous deployment, as the name implies, you are continuously deploying every change that successfully makes it through compile and test automatically to the production environment, or at least to a production slot. Whereas continuous delivery, we're just ready to deploy it because we've done all of our compiling and testing. Maybe even we've done some more exploratory testing, manual testing, and even some automated load and stress testing. But in any event, the solution is ready to be deployed. It's just not deployed yet with continuous delivery. With continuous deployment, as the name implies, we have actually deployed the solution. So now that the solution is deployed, the operations team is going to want to make sure the systems and deploy the code onto the production environment in a consistent way. For that, we need configuration management to help make sure that the systems are configured in a consistent state and functioning properly for the version of the software that's about to be deployed. This avoids configuration drift and incorrectly configured devices. Using a configuration tool like Ansible, Puppet, or Chef, we can make sure that the configuration happens automatically and in a consistent way, so every deployment is either successful or fails the exact same way it failed last time, because the failure was part of the automation. Some DevOps tools that we can use for these configuration operations are Puppet, Docker, Chef, and Ansible. Now, these tools are the most common tools used for this deployment and configuration automation phase of our DevOps delivery pipeline. So again, configuration management is the process of systematically managing and handling changes to a system in a way that maintains integrity over time. How does it do that, you might ask? Well, it does that by doing the configuration in an automated and consistent way. So the same way we take our code and we compile it, we test it, and make sure that it passes those tests and compiles successfully, we can take our configuration and do that in the same automated way. And once we have a configuration automation script that works successfully, we can then take that configuration automation script, that playbook, that recipe, or what have you, and store it in the source code repository along with the rest of the solution artifacts, the code, and any documentation that we might have collected or created over time, and put it in that central source of truth, GitHub, our central repository, or whatever tool that you choose. Now we have everything either in our artifact repository, that would be the output of our build, our deployment package, or in our source code repository, which is all of our source code, documents, configuration files, and so forth. We have a central source of truth for all of the resources necessary to successfully deploy this solution. So even if we had nothing more than our source code repository, our artifact repository, and bare metal resources, we could reproduce this solution. So Puppet's an open source configuration management tool for deploying, managing, and configuring multiple servers in an automated way very consistently. So we basically have the notion of nodes, or the puppets, if you will, that are controlled by the puppet master. So what basically happens here is the node sends the data about itself to the puppet master. The puppet uses that information to compile a catalog that shows how that node is supposed to be configured. But if over time something changes and that node reports back to the puppet master that the configuration is incorrect, incomplete, or has changed something that's non-standard, then the puppet master can then push down updated configuration to keep that server in a standard state, consistent with its stored configuration and all of the other nodes that are necessary for that solution to run. Now, as far as deployment to these different servers and configured resources, an easy way to make sure that deployment is consistent is to really avoid the redundant configuration and deployment of those solutions to multiple servers individually by deploying into a container and then using that container to replicate that configuration across multiple devices and resources. Containerization is basically the process that allows software to run reliably when moved from one computing environment to another, because it's not dependent on the local computing environment itself, rather on the container host, if you will. Basically, a virtual machine requires that we use up a lot of resources and install a full copy of the operating system inside of that virtual machine. And that virtual machine basically needs all the same hardware that the operating system needs to run. Containers, on the other hand, live inside of that host machine and effectively are segmented from all of that hardware and requirements of having a full operating system. They're basically small containers inside of the existing operating system. So we get the same level of isolation without all the overhead requirements of having a full virtual machine with installed operating system. This allows us to easily deploy the containers without all the headaches of installing an operating system and redoing the configuration. So Docker containers are basically standard units of software that package the code and all of their dependencies so that the application runs faster and it's reliable from one computing environment to another, again, because it's not dependent on the underlying hardware or even the underlying operating system, but just the container host. So the operations team verifies that the website is functioning correctly and the entire architecture is working properly. And once it is, then we can continue to monitor the website on an ongoing basis and make sure that performance doesn't degrade over time, to check and see what features users are actually using and what features that they're not, so we can send that feedback back to the development team so they can make changes as needed to make sure that we're meeting the requirements of the customers. So operations team monitors, collecting feedback from the website, and doesn't do us much good to collect that feedback if we don't have an easy way to push that feedback back into the team that built the solution in the first place. So some tools that we can use to collect that monitoring information, to collect that ongoing usage information are Splunk, Nagios, and New Relic tools I'm sure you've heard of before for monitoring on the enterprise scale and being able to collect that log information, to collect that monitoring information, those key metrics, and display them in an easily consumable way. So basically monitoring is that process of detecting, examining, and reporting if there are any faults or threats in the entire infrastructure. So not just with the hardware, but also with the operating system, with the software that's running on that operating system, with any of the containers, with the network, with the memory, anything that might impact in a negative way the execution of our solution should be collected and alerted on using our monitoring tools. So Nagios allows you to monitor the server and check and see if there are any underutilized resources or if there are any task failures that need to be addressed or any other critical issues that might cause a negative impact to the service of our customers. So basically, Nagios has a plugin that we install that allows it to load resources or log data or alert information from those remote servers and send them to a central location where they can be aggregated and displayed through the web interface. This allows operations team members that are monitoring those systems in production to easily see and aggregate that data, so they don't have to go and look at individual reports from every single server that they're responsible for. If there's a problem, then the tool will notify the admin about the status or of whatever resource is having an issue.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
And in this demo, we are going to demonstrate some of the uses of the common commands in Git. So we're going to use git version to check our Git version. We'll use git help to list some of the help commands there. And then we'll use git commit, git add, git init, and git status to manage a basic Git repository. So let's go ahead and get started. You can see I'm on my C drive in a Git repos folder here. So I'm just going to right click and say git bash here. So I'm going to open a bash command prompt here, and we'll increase the size of the font so you can see it better there. And here we'll start with just git version. You can see I'm running git version 2.21.0 for Windows. And to see what's in this folder, we'll do an ls. As you can see, the folder is empty. I do not have any repositories yet. So I'm going to do a make directory, and I'll make a directory called hello Java. See, I've got my hello Java folder now, so I will change directory into the hello Java folder. And here we'll do a git status to see if this hello Java folder is a repository. No, it is not a repository yet because we just created it. So we're going to do a git init to initialize this repository. And you can see now at the end of the command prompt here, we have master, indicating that we are in a Git repository and we are on the master branch. So now if we run a git status, it says we are on branch master. There are no commits yet, and there is nothing to commit. So let's create a new file, and we'll create the file hello.java. You can see we have that file. Now I'm not going to bother with the Vim editor in here. I'll show you why in just a few minutes here. But I'm going to go into my hello Java folder, and I'm just going to edit this file using Notepad. And I'm just going to create a very basic class here. And my class is going to be called hello. So I'm going to create a public class hello, and my public hello class is going to have a single public static method, that's spelled static correctly, that returns no values and is called main. This method accepts a string array as the argument list. All this function is going to do is simply print something to the console. So this will print hello world to the console. So we're going to do that by doing a system.out.print line, and what we're going to print is hello world. Can't have a programming demo without at least one hello world, so there it is. So that's our class. I'm just going to save our class and close the editor here. You can see we've got our Hello Java file there in the Windows Explorer. Again, double check that it's here, and we'll do a cat hello.java to see that we do have those contents of the file. Now, if we do a git status, you will see that we have our Hello Java with untracked changes. So in order to be able to commit our new Java file to our repo, we're going to have to do a git add and the name of the file we want to add, in this case Hello Java, adding it to the staging area, where if we do a git status, we'll see now it's green. It's a tracked change, but it still has yet to be committed to the repository. So to commit, we're going to do git commit. Now normally what I'd want to do is put a -m in my commit message, but I want to show you why I didn't use the Vim editor earlier. By doing a git commit, and it says, hey, you have to add your commit message, so here's this text-based editor for you. I'm not really a fan of this text-based editor, but if we start typing, we get the insert command, and we can type added hello.java file. And then we have to hit escape to get out of insert mode, and then we have to type :x, enter to save and exit. In the case of creating a file, to open Notepad to create the file, or in the case of committing, to just use the -m switch and put your message right there on the commit line. We do our git status again. You can see that we now have nothing to commit because we have committed our change already. Now, the next thing that we might want to do here is to push our changes to a remote repository like GitHub. But if we try to do a git push, normally we would call that remote repo origin, and we'd want to push to the master branch. If we try to do that without first specifying where that remote branch is, it's going to give us an error message. And the error message basically says, origin does not appear to be a Git repository and could not read from the remote repository. Make sure you have correct access rights and the repository exists. Make that message a little more clear. If we delete where we were trying to go and we just do a git push, it tells us that we first need to specify a remote repository using git remote. So if we do git remote add origin, it wants then the URL to our remote repository. So to get to that, what we'll do here is we will launch a new instance of the browser, and we will go to GitHub. On GitHub here, we are going to first create a new repository. Call our new repository Hello. Let's call it Hello World. We'll accept all the defaults here and create our repository. And then it gives us here the URL to our repository. So I'm just going to copy the URL to the clipboard and then switch back over here to my git remote add, and I'm going to paste in the URL to that repository. Now I have a reference to my remote repository, and now we should be able to successfully commit our changes to that remote repository. But before we do that, let's take a look at the repository. You can see this repository has no files in it. It's completely empty. It says we can create a file or upload an existing file or import code from another repository. All we are going to do is complete our git push to the origin master, enter. And after a few seconds here, you'll see that our push completed successfully, and we can switch back to the browser and do a quick refresh. And you can see that our one file hello.java has been added with our commit message added hello.java file or class in parentheses. So at this point, we have created a file, added it to our local repository, and then pushed that file to our remote repository, where we then might be able to share that file with other developers or other team members working on this solution. We are going to do another demo here on Jenkins. And in this demo, we are going to first create a basic Jenkins job to run a Windows batch command. And then we'll build another Jenkins job that pulls a very simple Java class from GitHub and builds that Java class and executes it as part of our Jenkins job. So first thing, let's take a quick peek at Jenkins here. And in Jenkins, a couple of key locations that you're going to want to be aware of are are the Manage Jenkins area here. And inside of Manage Jenkins, we have the area where we can do our global tool configuration. And this is where we would set up tools like Maven for compiling our solutions, the JDK for accessing Java. There's our Maven access. If we want to set up Docker containers as part of our Jenkins jobs, we'd also want to set up a reference to our Docker installation here. We're going to do a pretty basic demo, so we won't have the need for any of these tools. But if we go back to our dashboard and then back to Manage Jenkins, there's also an area here where you can manage the plugins that are installed in Jenkins. Now, here shows the updates that are available. And since I just installed Jenkins and loaded all of the updates, there are no new updates available. But if we click on the Installed tab, you can see all of the default, or rather recommended, plugins that Jenkins loaded after installation. After installation, it'll basically ask if you want to do a manual installation of just the plugins that you want, or if you want Jenkins to go ahead and install the recommended plugins. And this is what you get if you install the recommended plugins. For our purposes, in a later demo, we'll be using the Get plugin. And you can see here that's installed by default as part of that recommended setup. Okay, so we're going to start by creating a new Jenkins job. Pretty basic Jenkins job here. And we're going to call it Hello Jenkins. You can see I've done this before. We're going to set that as a freestyle project so we can build it from scratch. And in this demo, we're not going to pull anything from GitHub. We're just going to send a very simple command. And so we're going to scroll down to the build step. And we're going to add a build step called execute Windows batch command. And in this Windows batch command, we are just going to echo something to the console where we're going to say hello from the Jenkins job. And we're also going to display the date and the time that this request came in. And then we'll go ahead and save that. And now when we go and build this project, very quickly we get a success because there wasn't much to execute. And then if we click on the build there and we go look at the console output, you can see that we successfully ran this job and printed to the console, hello from the Jenkins job, Wednesday, 3/20/2019, 15:39 and 29.96 seconds. Success. So let's up the ante a little bit. Let's go back to the dashboard, and now we'll build another new project. This project, we'll call this one, yeah, you guessed it, Hello GitHub. And again, we'll make it a freestyle project so we can build it from scratch. And we're going to tell it that we're getting this code that we want to build from our remote repository. So it's going to want the URL to our remote repository. Just so happens I have that open over here. We're going to get our Hello World repository here. So I'm going to grab the clone or download and copy the link to the repository. Once I have that link, I can come back over here into into Jenkins, and I can paste that link to my GitHub repository. Now, if your repository requires authentication, you'll want to go and add that credential in your Jenkins credential provider and add those additional credentials that you want to use here. I believe I've already added the credential for that GitHub account. So all we need to do now is just add our build step. And our build step in this case is again going to be a Windows command, or Windows batch command. And we're going to do Java C for the Java compiler, and we want to compile hello.java. And then we want to run, using the Java runtime, the hello Java class that we just created. So now we can go ahead and save, and then we can now build this job. A small delay while we compile, and the blue sphere there means that we were successful with our compile and run of this job. And if we go and look here in the console output, we can see that we compiled our Java hello, and then we executed our Java hello and got Hello World on the console. That concludes our Jenkins demo.
And in this demo, we are going to install Puppet and the Puppet agent on 3 nodes in AWS. So to that end, we'll create 3 instances in our AWS console here. We'll start with the Puppet master instance, and we'll create that on an Ubuntu server. And we're going to use a T2 medium with dual core CPUs and 4 gigabytes of RAM. Now we're going to put it into a security group that has all ports open, just so we don't have to deal with any firewall issues. And we'll just double check in the instance details, subnet usage. We'll let it go ahead and create its own subnet here, and then we'll review after it's created to make sure that our other nodes end up in the same subnet. As for tags here, we're just going to add a new name tag, and we're going to say Puppet Master. And then we will launch the server. We're going to use the Oregon key here, since we are using the Oregon data center. Go ahead and launch that instance, and we'll view this instance again just to review the subnet ID that it's on, and it's on subnet with the last 3 characters of 4D4. So now we'll go ahead and launch our 2 nodes, again using Ubuntu Server. This time we're just going to use the T2 Micro, 1 CPU, 1 GB RAM, because it's in our free tier, eligible tier. So we'll go ahead and again set the security group to everybody all in, review and launch, and then we'll update in the instance details the number of nodes. We're going to get 2 nodes this time, 12, 2 nodes this time, and then the subnet. Again, going to use that 4D4 subnet so that we can access the master node, and then we'll add a tag, a name tag called Puppet Nodes, and review and launch, and we'll launch those nodes again with the Oregon key, and we'll launch those instances. All right, so if you view our instances, we've got our Puppet Master, and I'm going to edit these names here and call this Puppet Nodes 1, and we'll call this one Puppet Nodes 2, just so we can keep track of which is which. Now, first things first here, we want to connect to our Puppet Master using PuTTY, and to do that, we're going to use its public IP address. And then we'll go launch PuTTY here. I've already got a setting here for Puppet Master, but we need to paste in that updated IP address. And then just to make sure that we are using the correct key, there's our Oregon key. Now we can go ahead and connect. But before I connect, I'm going to go ahead and save that. And now we have a connection to our Puppet Master. And then, now that our nodes are up, we'll connect to the public IP of our Puppet Node 1, again using PuTTY, agent connection here, paste in our proper IP address, and again just double check to make sure we're using the right certificate, and no we're not, so let's change that to our Oregon key, and again we'll save that just so we can reference it easily later. I'm going to move this window over here and then go and connect to node 2 using its public IP. And again to PuTTY, we'll use that same agent setting. We shouldn't have to double check and make sure that the certificate is correct because we just saved it, just in case anything's gone horribly wrong. Yes, we see we're using the same Oregon. I'm not going to save this one. I'll just switch the IP back and forth. Now we have a connection to our second node. So we now have node 1, node 2, and our master node over here. So now we can begin to add our settings. So first up on our Puppet Master, we are going to set its host name to Puppet. We're going to do that using the hostname ctl set hostname command. And we're going to do that using a super user do and set that hostname to Puppet. Now we'll do the same on the nodes, setting them to Puppet Agent and Puppet Node respectively. But before we do that, let's go ahead and edit our host file so that we can tell the system what the local IP address is for our Puppet Master. Now to do this, we're going to go back over to AWS. We're going to grab our Puppet Master and grab its private IP address. Then we'll jump back over to our Puppet Master's host file, and we'll paste in that IP address along with the name of our server, Puppet. And then we'll use Control X, Y, and enter to save that file. Now we'll do the same on each of our Puppet nodes. We'll first set our agent to Puppet Agent, and then we will set our node to Puppet Node, and then we'll go back and edit the host file on each of those machines. And again, we're going to grab that private IP for our Puppet Master, and we'll include that as well as the name of that server. And we'll do the same down here. And then Control X, yes, to save the changes. Enter to save to that file name. Control X, yes, to save the changes, and enter to save that file name. So now that we've got the basic DNS info set up, we can continue on with installing resources on these servers. So to do that, we're first going to do a sudo apt get update to update the package repository. And we'll do that on all three of these servers here. First on the Puppet Master, then on the agent, then on node 1, then on node 2. And once our update is complete, we will then do a wget to set the Puppet Labs installation repository. And since we'll need to install the Puppet Master on the Puppet Master, obviously, and then the Puppet agent on each of our nodes, we'll use this same statement on all three nodes. So wget https://apt.puppet-labs.com/puppet-labs-release-pc1-exenial.deb. Go ahead and execute that on the Puppet Master, on node 1, and on node 2. Then after that, we want to reference the package, again on all three nodes. Sudo dpkg-i puppet-labs-release-pc1-exenial.deb. Again, we'll execute that on all three nodes because we'll need access to that repository to install both the Puppet Master as well as the Puppet agent on all of our nodes. And then we'll do a git update to update our package repositories again. Again, on all three nodes, we'll do that. And finally, on the first node, we can go ahead and install the Puppet server. So we'll do that with a super user do apt get install puppet server -y. Now obviously that's going to be a little bit different than what we do on the Puppet agent on our nodes. So on those additional servers, we're going to execute super user do apt get install puppet -agent. So Puppet agent this time instead of Puppet server. So sudo apt get install puppet -agent -y. We'll do that on both of our nodes here. And then we'll jump back to our Puppet Master so that on our Puppet Master we can complete the configuration by editing the Puppet server configuration file. And we'll do that with the super user do using the nano editor to edit etc/default/puppet server. Now in this file we need to modify the Java args so we can adjust the memory allocation for our Puppet installation. We're going to change that from 2 gigabytes down to 512 megabytes. So do that by adding XMS 512M and XMX 512M to the Java args. And then again, we'll Control X, yes to save, and enter to save to this file. Now that we've got the memory configured, we can go ahead and start Puppet server. And to do that, we'll use systemctl start Puppet server. Super user do systemctl start Puppet server. And once we've started the Puppet server, then we can go ahead and enable it for auto start when the system starts back up again. And then before we can go any further on our agents, we'll want to set up a manifest file to install something on those agents. And for this demo, we'll do something pretty simple and straightforward. We'll go ahead and install Maven so that we can later build Java projects. But first, let's enable our Puppet server for auto start. Now, our server is up and running. We can check the status of our server using systemctl status Puppet server. Check and make sure our Puppet server is up and running. We can see here that it is active. It's up and running. That means we can now go ahead and add our Maven manifest file. So we'll do that this time using the Vim editor. And we'll do that with the super user do Vim and then the path to our manifest. etc puppet labs /code /environments /production. So we're working with the production environment here. And in the production environment, we have a manifest folder that we are going to create a file called maven.pp in. Now in this file, we're going to specify a node configuration for default nodes. So that's every node that we encounter. We're going to set up a package, the Maven package, to be installed. So we're going to ensure that that package is installed. Then we'll close our package reference as well as closing our node configuration. And then we will enter to save that file. All right, so now that we've got our manifest file over there, we can go to our 2 Puppet nodes, and on those Puppet nodes, we can edit their Puppet configuration files so that they can reference the environment that we want to install our configuration from. So we're going to edit using nano again, using the path etc/puppet/puppet/puppet config. And in this file, we are simply going to add a reference to a main section, and then we'll include cert name, and we'll set the cert name in this case to puppet-node1, and then the server equal to puppet, and the environment equal to production. And again, we'll control X and Y to save, and enter to save to that file. We'll do the same down here on node 2, and again, we'll create a main section. We'll add a reference to the cert name, puppet-node2 this time. And then the server will still be Puppet, and the environment will be production. And one more time, we'll control X, yes, and enter to save the file. Now that we've got that set up, we can go ahead and start our Puppet agent service. So we'll do that with the same command that we used earlier, sudo systemctl start Puppet this time instead of Puppet server. Both servers, and then we'll configure those servers for auto start. And just to make sure everything is doing what it's supposed to be doing, we'll try to telnet to the Puppet server. You can see there that we have successfully connected to Puppet on its private IP. The same thing down here on node 2. Make sure node 2 is good. Also successfully connected to Puppet. So now we can go back to our Puppet server, and the act of starting the Puppet agent service on each of our nodes should have sent a certificate signing request to our Puppet master, just to make sure that we have secure communication. So let's take a look at the cert list on Puppet to see if we have a list of 2 certificates. To do that, we're going to use superuser do, opt puppet lab /bin, and puppet cert list. This should give us a list of the cert requests that have come in, and you can see there we have one from node 1 and another from node 2. Now we could either sign these requests one at a time by adding puppet node 1 and then puppet node 2, or we can sign the requests all at once using this command, superuser do /opt /puppet labs /bin /puppet cert sign -- all. That will sign both of those requests with one command instead of having to execute 2 separate commands. Successfully signed both of our cert requests, and now we can go and execute our configuration. Now, before we do that, let's just double check and make sure Maven is not installed here. If we try to do an mvn -- version, we get a message that says command mvn is not found but can be installed with sudo app install maven. So that tells us very clearly that mvn is not installed on either of these nodes. So now we can run a superuser do opt /puppet lab /bin /puppet agent test. And this will attempt to go out to the master server, the Puppet master, and retrieve manifest files that are configured for this node, or in our case, default, which is all nodes that connect, and then it'll install whatever's in the manifest. So we'll run that first on node 1, and then we'll run that same command on node 2, and you can see that ran very quickly in 0.04 seconds. And now, if we run mvn -- version, you can see that Maven 3.5.2 was successfully installed on both nodes. And that concludes our demo of Puppet running on AWS.
So from this section, the key takeaways are that DevOps is largely an organization-wide cultural shift. It's mostly cultural. There's a lot of tools, there's a lot of technologies that we'll talk about, but for the most part, DevOps is a cultural shift from one way of doing business, from one way of developing software, to a new, more agile, optimized way of delivering software and resources. To do that, that, we need tools, obviously. So things like version control, we talked about Git and GitHub. And once we have some changes loaded into version control, then we also need to have some system in place that can detect those changes and then make sure that those changes haven't introduced defects by making sure that they still compile or build. And after we get a successful compile, making sure that those changes pass the tests and that automated tests that we have in place don't start failing after we've made a change. And then using those same tools, we want to make sure that we get that successfully compiled and successfully tested solution off into an environment where we can do more exhaustive testing, where the QA team can do some manual testing, some exploratory testing, or do more in-depth automated testing. And then finally, we want to move into an environment where the operations team can make sure the configuration is done correctly. We can make sure the infrastructure is in place before we begin to deploy in an automated way to those production environments. And again, with that deployment, we want to make sure that we're doing it in an automated, consistent, and reliable way. So we want to use an automation tool like Puppet or Chef or Ansible. Now, to simplify the deployment process and make the deployment process more repeatable, we can use containerization and containerization tools like Docker to allow us to deploy in a repeatable, reliable way while minimizing the need for excessive operating system configuration or dependency on multiple virtual machines. And finally, using log aggregation tools and monitoring tools like Nagios and Splunk and Elk, we can collect all the information from these multiple servers on our DevOps delivery pipeline and make sure that we're alerted instantly if anything happens that would negatively impact the service to our customers.
Thanks for watching. Don't forget to like and subscribe.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.